Oh, no, class is starting. Just in the future, I'd like to go over my midterm with you, but not during class. So I
Oh
will
yeah.
shut up now.
Okay. Yeah. Anybody who wants to talk about specific stuff, I mean, I could take some general stuff. If you saw anything on the midterm you have a general question about, but if it's a specific, like, why did I get exactly this wrong? That might be after class or something. Um,
Yeah, I was going to try using the Grossmont tutoring. Do you recommend that, or should we just meet with you outside of class?
I very much recommend it. That's why I've got a link to it up in Canvas.
Okay.
So, has anybody tried it out this summer yet?
I was going to try today. I just fell behind on my homework.
The second announcement thing is about the tutoring, and I think I have another tutoring thing over here somewhere. I can't remember. There it is. Um, but yes, I do recommend it very much. Yeah, I mean, yeah. So somebody's asking me about appointments. You can always email me some options for meeting more than just my office hours if you need to. Sure. Otherwise, just come to office hours. I'm a little early. I logged in a little early today, and there were already people waiting for me, so I was neat. Um, Shoot, I lost somebody. Oh, I'm up to 24 people. I'm only missing 7. Um, oh, okay. Well, I am tomorrow. Do you guys remember what's happening tomorrow for us in this class? Anybody?
Not class.
You have meetings.
I have meetings. Yeah, tomorrow is gonna. Well, it's not gonna suck for me. They're actually really cool meetings, but I'm gonna be in meetings all day long. It's what's called the Curriculum Institute, right? You didn't think I could get any more exciting. I'm already a math teacher, but I'm also involved in curriculum. The wonderful, the amazing world. Oh, we get really, we actually do get pretty crazy when we get together. A lot of drinking and stuff to help us deal with talking about credit hours. But so tomorrow's going to suck in general for me. I'm not going to be able to do anything tomorrow. But Thursday, I could certainly come in early. I could start my office hours early if anybody wants to come in. That's fine. All right. Anything else? Can't do Thursday. You can do Friday. I can't do Friday because that's when more meetings are happening. Actually, Thursday more meetings are happening, but I didn't want to take too much time away from class this week. Can you give an example of how to make graphs of section 7? I need you to be a little more specific. Chapter 7 graphs. Which kind of problems are we talking about? By the way, somebody's privately chatting with me in case somebody thinks I've gone insane. Number 40. Okay. All right, hold on. Where's 40? There you go. Okay. Do what you need to do. All right, hold on. What did I miss here? Oh yeah, let me show you that in a minute. Let me answer this question, then I'll show you the average grade stuff in Canvas. I've forgotten what the question was now. Number 40, right? Number 40 in chapter 7. Draw the graph. Oh, it should be, to be honest, what's funny is you should automatically be doing this. I mean, all it is the picture we always draw, right? So the mean was 25. Oh, this is terrible, Jeff. All right. So the mean is 25. I want to know greater than 25.2. Shade in that's what number 40 is talking about. And you should,
Perfect.
yeah, you shouldn't have to. The funny thing is, you shouldn't need this problem to tell you. It should just be an automatic thing that you do. Yeah. Let me see. What am I missing? Oh yeah. All right. Let me show you this. Let me show you where these average grades are that I spoke of. Womp, 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 womp. All right. So I am now what is called a test student. So if I go to grades, right, if I scroll down, you will see these. Everybody with me? You want to play along with me? You can go into your own account. These are actually the overall average for the whole class. So right now, not counting homework, the average grade for the whole class is 75. It's not bad. To be really honest, there were 2 grades I should have taken out that were incomplete because they didn't take the midterm yet. So this is actually probably more like 78. So there were a couple grades that were really low because they had a 0 for the midterm, which is not true. Anyway, this is just to show you where your grades are. So for you, this will be different than for me. This is going to be all about you. What your average grade is if you had all the homework turned in and it was good. What your average grade is, not counting the homework at all. And what your average grade would be if you had no homework turned in at all. So everybody with me? Can you guys all find that? So the very bottom of your grades link, right there. Pop. Well, I got a chat. So how can we know we pass or no? What? All right. I don't understand. So these are your grade. So you know which one of these you're closer to. You know if you've turned in most of the homework and it's good or not, or you know if you haven't turned in any homework, right? So you know you're somewhere between 70 and 77, and you know which one you're closer to. Is everybody with me? Oh, I don't know, probably 12:30. I'll log in on Thursday at 12:30, okay? Anybody wants to come ask questions about whatever, Thursday. And I can stay after class today if that's better for some. Okay. Is everybody cool with the grades thing? Does everybody understand? I had somebody last semester who missed a lot of classes and then got angry at me because their Canvas grade said not applicable. And I'm like, I don't use Canvas to grade. I give you the grades myself. So everybody here now knows this. Okay. Of course, if I suck, you can always tell me. Department chairs that I suck. Any of your teachers that suck, you can tell the department chairs, this guy sucks and this is why. And that's fine.
Are the averages going to change as we turn stuff and it gets graded?
Of course, definitely. In fact, this is a worst case scenario because if you have not corrected things like, or I haven't graded, there are some quiz corrections I haven't graded yet. Some people have actually corrected the midterm. I haven't graded those yet. So, if I grade those and you get some points back, your score is going to go up. So these are not set in stone, especially not for my class, because I'll let you make corrections. And we have more quizzes and more tests and then a final exam. And depending on how you do those, it's going to go up or down. When we get closer to the final, I will include a line in your grades that says, final exam grade needed to pass. Somebody with me? So you have kind of like a target. Final exam graded needed to make a B. Hopefully somebody has a slightly higher aim than just passing, and maybe to make an A, right? Okay. So everybody okay with grades and how they work in my class? I do not allow Canvas to calculate grades because Canvas is stupid. It is. It makes mistakes. It does. So I don't let it happen. Of course, yes. Again, what's the only thing you're not allowed to correct in this class?
The final.
The final?
Yeah. Yeah. You can correct everything else once. There's no first draft, second draft, third draft. Don't return in something you've already corrected. Right? Don't do that. Okay, all right. Anything else before we get back into where we left off? Which I need to remind myself where that is. Did we finish that? I think we did. That central limit theorem practice sheet. Yes, we did. So last time we did this. Crazy sheet. Holy sheet. We did all of this. You guys remember doing that? No? Remember this, when does central limit theorem kick in? Anybody? There's two things that tell you.
When it says there's a sample of something and you know it's a normal distribution.
No.
Okay.
So when they take a sample, sure, of course, that's what we're doing right now. All right. So you guys ready? Central limit theorem kicks in when there's a sample taken and they ask questions about the sample mean. Let's take a look at the sheet again. Is everybody with me? Now, separate from that, right? That's what you get your gears going. That's when you have to divide by the square root of n. Does that sound familiar? I know it's been a while. We had Monday off. It's been a while. You had bright lights in the sky and things happen.
When they ask questions about central mean, sorry, I kind of ignored it. I mean, to a degree, because I was just so worried about the midterm.
Oh, all right.
I mean, it just like the information was pushed out of my brain.
Okay. So let's do this. Let's collect everything we know about central limit theorem up on the board. I like it. Let me turn off my background. Oh man, come on. Please work. There you are. Well, it's a panda. Faculty voice. Oh, freaky. Hold on, there it is.
Is that Star Wars right back there?
Oh, hell yeah. All right. Does anybody know what that is? Nobody? Anybody know what that is?
Is that like an angry bird pig thing?
No.
It looks like an angry bird pig.
If I say chookity. No, okay. That's all right. No worries.
Stitches below it.
Fat baby Yoda.
Stitch is below it. That's right. Good. So you got some points for Stitch. I like it. Wow. It's kind of dark here. Hold on. Is it just light? Yeah, this is not bad. All right. So central limit theorem. Actually known as chicken, lettuce, tomato. As n gets larger, sampling distribution of sample means becomes more normal. So this is a point that I don't think I necessarily made, but as n gets larger, the resultant distribution of means becomes more normal. Now, of course, I think you all know the cutoff. If n is what, then it's normal enough.
30? Is it greater than 30?
Greater than 30, I like it. So if n is greater than 30, it's normal enough. The mean stays the same. The standard deviation becomes this for sample means. X bar. So all this is saying is, when they take a sample big enough, and they ask questions about the sample mean, you've got to do this before you find z-scores and so forth. This is the only thing that actually changes. It's just you got to know when it's supposed to happen, right?
Does it have to be more than 30, or can it, like, does 30 itself count as normal enough, or has to be greater than 30?
Technically greater than 30. If,
Okay.
I really want this to make sense. Does this distribution, I know it's small, but just deal, does this look normal at all? That distribution?
No.
Not really, no. So it would need more of a sample size than, is this normal here? Is this normal? This one? Is it normal?
Yes.
This one? Is it normal?
It's
No,
still
it's equal.
It's not normal, but it's pretty close, wouldn't you say?
Yeah.
It's pretty close. So I really want this to make sense. This would need less than 30 to become normal because it's already close. This would need more than this one, right? So imagine the most disgusting distribution, it would need more than 30. So in general, if you don't know what it looks like, you have to assume the worst. So then you assume everything needs greater than 30, unless you know it started off nice. Then less than 30 might work. Are you guys with me? Because again, what do we do in chapter 6? Is this normal? Does that look normal?
Yes.
So what sample size do I need to be able to do a problem here? Just like chapter 6, right? If they tell me it's normal, now get this, you ready? Here's a note, right? If they tell me the distribution is normal, the sample size can be anything, and it still is normal. I don't need it to be greater than 30 to save my ass because it already told me it was normal. If they don't say anything about it, then I need the sample size to save my ass. Does that make sense? Ann, what's up?
So there was an example about African salaries and like the poverty level, and that there's a lot of people below poverty level. And there's very few people that are very wealthy, very few people that are like middle class. That distribution would never become normal, even if you took enough people, wouldn't it? Because there's so many of those like high outliers. Or would if you took enough people that graph could look normal?
Yep, if you take n greater than 30.
Okay, that makes
I really want this to make sense too. It's not the same graph. You're taking, so the original graph is individuals. Then you create a new graph based on samples of size, whatever, greater than 30, and you plot the means of those samples. Each sample will be kind of an average of the whole thing to begin with, right? If you randomly select 30 people, don't you expect their average to be close to the real average? Does that make sense? Is it possible they won't be? Of course, but shouldn't it be more likely that they are closer? That's why it ends up being normal. That's why it ends up being skinnier, because more groups would be closer to the mean. Sure.
Are we saying, when you say groups of 30, is it like, could it be like 5 groups of 31 people, or is it 31 groups of 5 people?
Has everybody got what they want from this?
Mm-hmm.
All right, now stay with me. This is beautiful. All right, let's say I'm in chapter 6, and they tell me the mean is 111, the standard deviation is 21, and it's normal, right? You with me? And I wanted the probability is x is greater than 100. Who gives a shit? Whatever. What's the first thing you should do? First thing that we do together.
Oh yeah, I was gonna ask, in that case, are you saying x could also be equal to 100, or just x is
Why doesn't that matter?
greater than 100.0001?
Real quick, why doesn't that matter? What's the area of a single data point?
0.
0. Including 100 would not change this at all. This is assumed to be a continuous distribution.
Oh, okay. That was a question I had from home. Thank you.
It's a good question, but remember that these are when we say something's normal, we're assuming it's continuous. And there are situations where I give you something that's not really continuous, but I say it's normal, which means I can treat it as if it's continuous. So the normal curve itself is continuous, which means any single, the probability x equals 100 is basically 0, so it doesn't matter if I put that line or not.
So we want to find the z-score so we can find the area.
What should we do first?
We should
Graph it.
There it is. Beautiful. We should draw the picture. When you draw this picture, who the shit are all these people? Didn't I just draw a lot of people? Whatever this thing is. Maybe this is average bowling scores for people. Aren't there a lot of people in this picture? This is everybody? And then here's 100. Here's 111. And I want to know the probability x is greater than 100. Oh shit, Jeff. You can get it right. Here's 111. Here's 100. And I want to know this area. You guys, but I really want to stay. Do you guys understand when you draw this picture? We're talking the probability that one person is more than 100. But doesn't this picture represent all individual people's bowling scores? Are you guys with me? I really want you with me. When you draw this picture, you are representing everybody is in this picture. And we just want to know what's the probability that somebody is in this area. So when I do this, we take a sample of 45 people. What's the probability that the sample mean is greater than 100? Well, then this picture is going to represent groups of 45 people, every group of 45 people, because there's got to be a population that I'm kind of referencing here. So this is what the picture would look like for every group of 45 people. And I want to know what's the probability that this one group of, 45 people ends up in this area. All right. Now, to be really honest, I have forgotten the specific question that set me off on this course, but hopefully I addressed that. I think it was Jordan asking about, is this 5 groups or something?
No, I was just asking you to
No.
review the central limit theorem.
No. I meant this specific topic. It was Jordan asking about how many groups are we talking about. So we're talking about if I did pick one group of 45 people, what's the probability they would be here in the graph of every group of 45 people? The same way chapter 6 is, this is every individual. So what's the probability the individual is in here somewhere?
So the literal difference is individual and group?
That's it. Have you guys picked up on that? Do you guys remember how much I try to identify and just specifically say, I can't use this standard deviation here because this is for individuals and I'm talking about a group. So the very first thing I do here after drawing the picture is change from an individual standard deviation to a group standard deviation. Good questions. Don't get me wrong. This is excellent. These are the things that I sometimes maybe forget to kind of emphasize. I just need to know if something's not getting through. And some of you guys are like, I don't know what the hell this guy just said for the last 10 minutes. I'm sorry if you feel that way. I really am. Okay. Anything else in general? Anything? From 6
So for example, the fraction is going to be 21 over 45.
Say again, sir.
The fraction, yeah.
Sorry.
The sample.
Oh,
So
here.
it's going to be, yeah. The standard deviation is going to be 21 over 45.
No, 21 over square root.
Oh, okay.
So let's do these problems real quick. Let's see. What's the next thing I have to do on this first one? I've got the picture drawn. What's the next thing I've got to do? I think somebody said it earlier.
Find the z-score.
Find the z-score. So my data point minus the mean divided by the spread.
Negative 0.523.
Negative 0.523,
23.
so negative 0.52.
Yeah.
All right, sounds right. All right, nobody's yelling at us. And then what would you do? Got the z-score, negative 0.52.
Get the probability and subtract it from 1.
Yes. Look up the probability, look up the area in the chart, and then do 1 minus that to get the area on that side. So if you just look up negative 0.52 in the z-score chart, you'll get the area below, and then do 1 minus that to get the area of it. Okay. Now, the only difference, I almost don't care about the answer. I think most of you guys feel, tell me if I'm wrong, but I have a feeling most of you guys feel decently comfortable about this problem. Nothing special's going on. I give you a mean, a standard deviation, and a
1.5.
you make a z-score, you look it up, right? Okay. This one is exactly the same. I don't do this step until I get the correct standard deviation, right? So whatever the hell this is, I think it's going to be 3.
So that's the answer is 69%. I know you don't give a shit, but I just wanted to check.
Oh, up here?
Yeah.
So you got 0.3.
0.6985. So 70% if you round.
You got 3015 here?
Yeah.
Okay. All right. Nobody else said anything, so I'm going to take it. 16985. Okay. And then here, before you make a z-score, I can't use that standard deviation for because it works for individuals, and this one is a sample mean of a group. So I need to do this. And I don't know what that is.
3.13.
3.1.
3.
3.13 what? Is it 130?
Yeah.
Oh, it's 130.
130. Yeah.
Okay. And then you do exactly the same shit. You make a z-score out of 100, but now you divide by the correct standard deviation. Whatever the hell that is.
What just happened there?
What do you mean?
Oh, okay. I see.
So this had to happen because we're talking about a sample mean of a group. So I can't use the standard deviation for individuals. I've got to use the standard deviation for a group of size 45, which is what this formula does.
So it's standard deviation of the absolute value of x.
Stop. No absolute value up here. There's no absolute values up here anywhere.
What's the line over x mean?
What's the line over x mean? Anybody?
Sample.
Sample mean. I like it. So this is standard deviation of sample means. Right? That makes sense because again, this picture is of all the sample means of all groups of 45. So what's the spread of the sample means? Do you guys remember when you put it in the calculator, doesn't it say sigma x in the calculator? So that's the standard deviation for the individual scores. That's why it's x. This one is a standard deviation for means because it's all about groups of 45. Okay. So this is negative 3.21. I don't know what this is. Who's gonna help me out though? So,
3.514
oh man, that's way off.
negative.
3.514. Oh, okay. And then you just look up the area and you have to do 1 minus. So all the work, I really want, you see how the bulk of the work is the same? The only thing that changed was I had to make the standard deviation something different because I'm not talking about individuals, I'm talking about groups. Now, I want to talk about something a little bit.
Wait, I got 3.13. Oh, that's just what you wrote. Fuck me. So.
No, I will not.
Oh God, I'm sorry.
Okay. So we got that. Okay, I'm gonna erase it and see what happens.
So then from there you would find the area below.
Yeah, you just look up, and of course on the chart it says 0.0001, which in this case I would agree because it is right next to negative 3.5. Are you guys with me? This is where it's kind of like off the chart. So then this will be 0.9999. So I really want you to notice what happened to this 30% that was out here. Didn't they all go in? So there's much less out here. They all, if you take averages of a bunch of groups, they will all be closer to the real average than any individual would likely be. I don't know if you guys are with me. Again, would it be more likely to find one person that's 7 foot tall or 30 people that have an average height of 7 foot? Which one is more likely to randomly find one person that's 7 foot tall or 30 people that are 7 foot tall on average? Which one's more likely?
One person.
Yeah, it's much more likely to find one person. That's not even very likely, is it, to randomly pick somebody 7 foot tall? But it's a hell of a lot more likely than to randomly pick 30 and they're 7 foot tall on average, because if I take groups, their averages get closer to the actual average and there's less left out here. All right. Okay. So what if, all right, let me say this. What if you did have a group of 45 people and their average was less than 100? Is that evidence that something weird is happening? That's something special about these 45 people? What's the probability that just happens? That you get less than 100 average for 45 people? What's that probability?
0.001 would be close to impossible.
0.0001. So if it does happen, either it was just one of those, 1 out of 10,000 chance, or there's something weird about these people, or something strange, or something special, or something whatever. Are you guys semi with me? So if I go check some water and I see the concentration of chemicals has a probability of 0.0001 of naturally occurring, I'm thinking, that factory upstream, what are they doing up there? Do you guys follow what I'm saying? This is accumulating evidence. If I find something happening, the probability of which is very small in normal circumstances, that is evidence that the circumstances are not normal, are not, be careful, are not, something weird is happening, right? The word normal means something else to us now, so I gotta be careful about that word. Are you guys semi with me at all? No? I suck. I stopped making sense after my first email to you. I understand. Okay. All right. So let me see if I can, let me build this up towards something coming up. Let's say that the average, I have no idea about this, by the way. What's the average SAT score nowadays? 1100? Is that too high? I don't know. It's probably too high. Let's say 1000. Is anybody taking the SATs? I have no idea. Let's just pretend. Some standardized tests. The average is 1000. The standard deviation is 150. Sure. This is not the SAT. This is the SOL test.
Shit out of luck.
There it is. All right. Now, let's say that I take 40 randomly selected students, and I work with them like in a study program. You can do it, Jeff. Like Kaplan or something. Have you guys heard of that? Kaplan? Anybody ever heard of something you guys have? In a study program. So something, some program that's supposed to increase your score in the SAT. Those exist. So say I take 40 randomly selected students who are about to take the SAT and I put them through this program, right? I shackle them to chairs in my basement and I force them to do this program. That might have some effect on their ultimate. What ends up happening is they get, on average, SAT score of 1060. Is this evidence that my program works? So this is a little more interesting question than the bare bones kind of questions you've gotten so far. Just all you get at first are just questions about, can you handle Z-scores? Can you look at the Z-score chart? Can you do the right thing at the right time? This is a more interesting question, right? If you developed a program, wouldn't you want to get evidence that it works and then you can put that in a commercial? It's been clinically proven to assist to raise your score on this much on average, right? Have you guys ever heard that? Been clinically proven to have you lose 3.7 pounds over the course of 2 months. Something, right? This is how the hell you do it. Can somebody tell me what to do to see if this is evidence of anything? Think about it. What is your first reaction? Is this evidence that I've helped these students?
Yeah.
Now, why do you say that?
Because it's a bigger number than the average.
All right. Is it possible that a group of 40 students could randomly have gotten a higher grade than 1,000 by themselves without my hits? So the fact that this number is bigger than that number is not enough evidence by itself. In fact, would you have been as impressed if I would have said it was 1,001? Would anybody? That is a bigger number than this, yes?
Yeah.
But if I just put 1,001 up here, you would have been like, Jeff, your program sucked. Even then,
technically,
I don't know yet,
one better.
right? So it's something to do with a very familiar idea. How far is this from this? Is it far enough to mean something?
Is it?
I don't know. Somebody's got to still help me out.
You'll want to find the standard deviation of the sample mean.
Good. I can't use this one for anything, which I haven't even heard anybody tell me what to do, but I agree. Before we do anything, we need the standard deviation for 40, for groups of 40, right? So what's the new standard deviation going to be?
It would be 150 over the square root of 40.
Good.
Would we write it using S instead of sigma because it's for a sample?
Oh, I love it. This is the population standard deviation, correct?
So we're looking for the sample standard deviation, right?
No. if I calculated a standard deviation from these people, that would be S. I totally agree with you.
The 1060, that's not a sample? Oh, that's not the 40?
This year?
Yeah,
Okay.
the 1060.
Stop. I love this question. We are not calculating the spread of individuals in this sample. That is what S means. Sigma is the spread of individuals in a population. S is the spread of individuals in a sample. Are you guys with me?
Okay, and we're looking at individual, like the total sample score.
I want to know what's the spread amongst every group of 40. How does this one group, what's the spread within all groups of size 40? That's what this does.
23.7171.
One more time, sorry.
23.7171.
All right. Now what should I do next?
Find the z-score.
All right, so let's draw a picture. Then we can find a z-score. So right in the middle goes what?
1,000.
Good. So the funny thing is, what we're doing is we're saying, if my program did nothing, then the picture for all groups of 40 looks like this. 1,000, here's my 1,060, and I want to know, and now here's the funny thing is, I want to know, well, let's see, which way I want to say this. I kind of want to know this area, because if that's really small, that means that that is far away from that. Now, to be honest, I understand. Couldn't we just calculate the z-score and see if it's far away? Do you guys agree with me? Right? Generally, what we do is we go one step further and we calculate the probability that it's that far away. So let's do this. What would the z-score be for this? It would be 1,060 minus 1,000 divided by, of course, the new spread. So how far away is this from expected?
$2.53.
153. All right, so what do you say just by that? Is that far away? Is that an unusual place to be?
Yes.
Yes. It's more than 2 standard deviations away. So that by itself, right there, that is evidence that my program did something.
This is assuming that you've repeated the program multiple times with different groups of 40
No,
students.
it isn't. The picture, I really want this to make sense, obviously. This picture is for the given situation, how any group of 40 people would do in the given situation. Stay with me. I can only say that my program has accomplished something special if it would be unusual for any group of 40 to get where my group got. Is it impossible for a group of 40 students to have an average of 1,060? No, it isn't, right? It's not impossible. We can look up the probability, can't we? But is it so unlikely as to be evidence my program does something? Yes. I would expect them, a group of 40, to be within 2 steps. And this one was 2.5 steps up. Can anybody help me out? What's this area up here? If you look up 2.53, what area do you get? So then I can do 1 minus, get that area over there.
.9943.
So this would be 0.0057. This, so I really want you guys to understand the 2.53, we can interpret that We know that's more than 2 steps away, which means it would be unusual. It would be unusual for that to happen randomly. I really want this to make sense. What was the only thing we could tell from what I told you that was different about this group of 40 students that might explain why they did something unusual?
They took
They took my program, not kick ass. All right. Do you guys understand at all a little bit? So what we're doing is we're saying, all right, what's the probability that that just happens? If the probability that just happens is kind of big, then who gives a shit? Like if I would have gotten 1,001, okay, that's more than 1,000, but the probability that just happens would be high, right? That's pretty close to the normal average, and samples are going to fluctuate. But this is so much higher. It got into unusual territory, and this is kind of the probability that something like this would happen in a normal situation. So the probability that it was just random fluctuations is 0.0057. So what's more likely? They just randomly did better, or they did better because of this program? Because of this program. Now, there have been situations like this where later it was discovered that the group wasn't really randomly selected. Are you guys with me? So if they really were randomly selected, I can make a commercial and say, look at my shit, and pay some money and do this, and you're great. But there have been situations like this where somebody found out, oh, that group you worked with, that wasn't random. Those were people that were already doing studying on their own, and they were good students. Do you guys with me at all?
Yeah.
Wouldn't those students have done better already than the average student? So if it came out that I did that, then all my study goes to shit, because then that explains why they did so much better, not my program. That's why the fact that they're random is so important, so that there's no bias that makes something happen that isn't your program or whatever it is, right? There isn't some other explanation as to why this happened. I really want you guys with me on this. So can I make a commercial now that says it's been clinically shown that my program will help you do better on the SAT? Yes. And I can put this. Now, is this a very large sample?
You mean the SOL?
My SOL program. Is this a very large sample? No. So somebody could point that out and say your study should be bigger. And then I'll say, I need more people to sign up and give me money, so then I can do it. Anyway, I don't know if that helped anybody. I really want, we need to start transitioning away from nuts and bolts. Can you do z-scores? Can you use the chart? Into what the hell is this shit good for in the real world, Jeff? Right? I don't know if anybody's felt that way. You're doing these problems of bone densities of women. You're like, okay, what does this mean? What do I do with this shit? What does it mean? I got an answer. What does it tell me? What I do? No, yes, maybe, no, maybe, yes. All right. By the way, I might as well throw this at you. This number right here, which is a number you guys might not have thought to do. I think some of you guys would have stopped here, understandably. This bad little boy is called the p-value. Become an E. It's called the p-value. It's a very misunderstood little dude. Oh, sure. Sorry, let me get out of the way. All right, you got it? So the p-value is going to come up again in a couple of, I think in chapter 9. Yes, chapter 9. Oh, what time is it? No, we're not quite ready for a break. I'm sorry. Should have brought a little bucket with you. Okay. Oh man. Jeez. Okay. Sorry. Go do what you need to. A few people with emergencies, I know. Okay. I'm gonna start to erase. Let's see if somebody yells at me. Anybody gonna yell at me? No. So what we just did is sort of related to what we're gonna do in chapter 9. We're obviously not ready for chapter 9. We're gonna do chapter 8. So we're gonna get into chapter 8 today. I don't know. Do more of you want to take a earlier break than normal? We could take a break right now if you want to. I'm cool with it. No?
Yeah.
All right, let's do it. I've already thrown the idea out there, so I need to stick to it. So what time is it? Let's see.
It's 2:20.
Come back at 2:35. You're gonna let us out a little bit early today, so it's not a bad idea. All right, we're starting back up. Where did I even look? Oh, okay. So I want to show you a couple things. One is related to what we just talked about with p-value stuff. So let me show you this. So this is a study of carbon dioxide content in inhaled air with or without face masks in healthy children. All right. So for all those, I'm sorry if you are one of these people, but for all those dipshits out there who think they can't breathe in a mask, that's what this is for. But notice something, it almost doesn't matter what this is about, okay? So in case that irked you, let it go, you're fine. Look at what they have running around in here. Let me see if I find it better. Okay, this is not very long. Right here, this little p less than 0.05, for example, or anywhere you see a little p number, that's the p-value I was talking about. The smaller that number, the less likely whatever it is they found can be explained by randomness. The more likely it's a real effect, it's a real thing. So that's why in articles like this one, in statistical analysis, you will see p-values given everywhere. The smaller the p-value, that is the less likely that it was just random chance, that it is a real effect that they found. So for example, oh Jeebus, age was associated with carbon dioxide content in inhaled air. So there was an actual real relationship between those two things. Because the probability that they just randomly looked connected in the sample is really low. It's less than 0.001. Okay. I don't know if you guys are with me at all. I just want to plant the seeds of p-value in your brain so that it'll grow and take you over, turn you into a stats person. All right. What are you? That's an ad. I love it. What did I want to do with this one?
Give it a teen.
Sorry?
Nothing.
What's this? Oh yeah, that's right. Okay. So this is something about plant-based or pescatarian diets. Ooh, this is bad. All right. That is so terrible. So I'm sorry. Look at this little section right here. This doesn't seem like much. I couldn't find anything better than this. Let me see if I can. This is horrible. This is the only one I could find real quick. Anyway, so there's gotta be better ones. I'm sorry. This is what we're gonna work on today, is in improving. So let me ask you this. When you take a sample and you find the sample mean, would you put money on that sample mean being equal to the population mean? So if I took a sample of 800 gross month students and I took their average age, would you put like a ton of money on the sample mean being equal to the population mean?
Yeah. I don't know.
And
I was
don't
going to tell you
mean-
though, if you're looking for those things that say blank to blank, there's another one 2 sentences down. It's just going. Nope, you went too far.
Yeah, right here. Yeah, I know.
Yeah. Oh, okay.
It wasn't
Sorry.
any more explicit. It wasn't really. Anyway, it's not a very good write up here. Oh well. What do I expect from somebody who has ads on their page? I don't know why I'm looking for studies with ads on their page. Here's another one. Okay. So look at this. This is just, I don't know. American pride ticks up from last year's record low. Take that as you will. The important thing here is, what's not important is, what's some of you guys, I don't know. Let's just say I don't own any red hats. Now, see it going up quite a bit. Shabba! So the important thing is, they asked this question. They asked a sample of people this question. So 69% of the people they talked to, they were extremely or very proud of being an American, of America, right? Are you guys with me? 69% of their sample. Do you think that that is the exact same percentage as all Americans? How all Americans would answer that question? No. Do you think it's close? Let me tell you one more piece of information. They talked to, this is why I love Gallup. They talked to 1,012 adults. So do you think that 69 is probably like, it's probably not equal to, but do you think it's kind of close? Yes, good. That is the right answer. And if you disagree with me, go ahead, tell me. I'll tell you right now, you're wrong, but I mean, it's fine. How many Americans are there? 330 million, I think, right? But a sample size of 1,000, if truly random, is completely fine to represent groups of a million or so, of millions, right? So here's what I really want to show you. Have you guys ever seen, for example, if you paid any attention to the last election, where you're watching like Biden, 48%, Trump, 46%, what would you see at the bottom of the screen? I think I brought this up once before.
Margin of error.
All right, Billy has wandered off. Okay, he's talking to somebody else. I don't need that shit. Now, anybody? Did anybody notice anything at the bottom of a screen when there's a poll about how you're gonna vote? Has anybody ever seen the plus or minus 3 or plus or minus 4%? No? Are you guys with me, anybody? I see a few of you guys.
Margin of error.
Good, yes, yes. So in this, they say it's plus or minus 4 percentage points. So it isn't actually 69. It's actually somewhere between, well, we got a little bit more to say about this. Somehow it's between 65 and 73. Is everybody understanding what I just said? Because it's plus or minus 4%, right? Notice something else though. Here's what's really gonna freak you out. What's your first impression of this? The margin of sampling error is plus or minus 4 percentage points at the 95% confidence level. I'm just curious. Go ahead, sorry.
Would you do 4 times 0.95?
Hell no.
That's the margin of error?
No. So are they absolutely confident that they're off by 4 percentage points?
No.
How confident are they?
95%.
What does that mean? No,
Pretty confident.
huh?
Pretty confident.
Pretty confident. I mean, that's more confident than I am normally. Shit. Right? That means there's a 5% chance they're wrong. And I'm like, for me, that is excellent. That's a really good day. Right? I don't know how you guys feel about it. But we still don't know what that, so we're going to get into what does this mean? How did they calculate 4? Where the shit did that come from? What if they were 98% confident? What would change? Are you guys with me? Not do you understand, but are you with me as far as what we're going to talk about? You don't know what 95% confidence means. I agree with, I think it was Patrina just said, if I were you, I'd say, well, that sounds like they're pretty confident. Not 100%, but they're pretty close. So what if it was 90% confident? Exactly what would that mean mathematically and conceptually? So we're going to talk about that today. Probably some of you guys are like, oh, it sounds great. So we'll see how it goes. All right. Now, so the whole thing this is about is if I take a sample and I get a percentage from my sample, or I get an average from my sample, is that really indicative of the population mean or the population percentage? Not necessarily, right? So don't we want to improve on that? If somebody said, how many people are coming? And you said 20. All right, so they're going to get 20 chairs. But what if you said 20, give or take 10? Are you guys with me? Give or take 10, so plus or minus 10. So how certain are you about 20? Are you certain about 20 people coming? If you're like plus or minus 10, you're not sure at all. You have a freaking clue. I'm going to get 30 freaking chairs and just be ready, right? Sort of like when I run a workshop and I have no idea how many people are coming. So I just make 50 things and then 3 people show up and I'm like, oh, good. Let's kill trees. But anyway, sorry. So the fundamental idea behind these things that we're going to create, these ranges, is to improve upon the one number we calculate, either it's average or percentage. We want to give a plus or minus to give somebody else an immediate idea of how certain we are, or how far away it might be from that estimate. Are you guys understanding? Does that make sense? If somebody's like, what do I need on the final to pass? And I say, you need a 65. It would be much more informative if I said, you need a 65, give or take 10 points, depending on if you make corrections. Are you guys understanding what I'm saying? So you kind of know how much you can affect that if I give you that range. Okay. So let's build this. All right, we're going to build this. It's not going to be a bear. I'm sorry. I'm not going to build a bear. Anybody likes my build a bear? Whoa, Jeff, jeez. Marker. All right. So let me do it this way. Let's start with something we know that I've actually asked you before. This is nothing new. This is old. We've done this before. You ready? This is going to explain a part of this. Can somebody please tell me what two z-scores contain 95% between them?
2, -2?
Not quite. I want to know exactly. That's the rough estimate we get from empirical rule, but I appreciate that. That kicked ass. But it's not quite exactly 2. I want to know exactly what it is. So it is roughly 2, but I want to know exactly what it is because I'm an asshole.
1.96.
How'd you get that?
I looked it up.
Yeah, that's a good idea, right? You got all these things with all these answers on them. Might as well look it up. So yeah, if you look at the z-score chart, I want to pull it up. If you look at the z-score chart, what am I going to look up in the z-score chart? I'm not going to look up 0.95. Well, how am I going to find the z-score? What am I going to look up? What does the chart understand? Areas that are where?
Below?
Below the z-score. So aren't there 2 z-scores I want?
Mm-hmm.
How do I find this z-score? Well, I need to know what area is below it. So what area is below that z-score?
2.5.
Good. 95, 5, 2.5. So if you look up 0.025 in the body of the chart, you look out, you will get 1.96 negative. Let me know if you can't find that. Get as close as you can to 0.025. I think it's pretty close, if not exactly that. I can't remember. Can you guys, has anybody found that? Does anyone need help? Does anyone want to say anything to me? Somebody's shaking their head yes, so I'll keep going. So then what's this one?
1.96.
So, get this. You ready? Get this. All right, let me see. Every time I teach this, it's a little bit different. So I'm a little excited. So the actual mean is somewhere in here. So if there was a certain data point, let me say it like this. If there's a certain data point that you want to catch, it's somewhere in this population, right? You guys said there's a certain person that you want to catch, and they're somewhere in here. If you want to be 95% confident that you will catch this person, how wide of a net do you want to throw out? Well, you want to throw out up 1.96 standard deviations and down 1.96 standard deviations. So when they were saying they were 95% confident that it was plus or minus 4%, that's exactly what they're talking about. I'm going to go up and down 1.96 steps. Why would that make me 95% confident that I caught something specific? Because how much do I catch? 95%. So if I throw out a net into a lake and I catch 95% of the fish, everybody else there will hate me. But how certain am I that I caught a certain fish? This one fish that I wanted to catch. If I catch 95% of the fish, what's the probability that I caught that certain fish?
95%.
95%, of course it is. So I would say that I was 95% confident that I caught that fish that I wanted, correct? Only a 5% chance I didn't. So somehow, when I'm constructing these intervals, right, from this to this, if I go up and down this many steps, I'll end up being this confident about what I'm saying. So what if I wanted to be more confident? What do you think? What if I wanted to be 98% confident? What do you think would happen to the z-scores?
They get wider apart.
Yes. So take a minute and see if you can find it. What are the z-scores in this case?
Hey Jeff, I have a question.
Yes.
How did you get negative 1.96?
Okay, this was what I was asking earlier. Let me pull up a z-score chart. Donde? You are here. There you are. Where's the other one? I'll also pull up the other one. Yeah. All right. You went too far, Jordan. I'm sorry I called you out, but so this one here, 0.025, right? Are you cool with that number?
Is that the z-score?
No, definitely not.
What's that number?
So this is 95%, right? Is that cool?
Yeah.
All right. How much is outside then?
5%.
5%. So how much is on that side?
Wouldn't it be 2.5%?
Exactly, which is 0.025 as a decimal, yes?
Oh, okay.
All right. So then if you look up, so let me pull up the z-score chart. If you look up 0.025, not out here, but here's where the areas are, right? The closest I get to 0.025, it's actually exactly 0.025. See that?
Mm-hmm.
So that is 1.96 negative.
Oh.
And because it's symmetric, it's exactly around the middle. If that's negative 1.96, that has to be positive 1.96.
Right.
Yeah.
Gotcha.
Now, did anybody get this other one yet? What area is here?
Uh, 0.1.
Careful.
0.01. Excuse me.
And so when you look up 0.01, what's the closest you can get to it?
Negative 3.4.
Everybody says that. Let me pull this up. Hold on.
I got negative 2.29.
It's closer. So let's see, 0.01. Closest I can get to 0.01 is right there. That's right on top of it.
Oh,
Right?
negative 3.49.
No, stop. I'm showing you right now. So isn't that the closest I can get to 0.01?
Why does that make sense?
What do you mean? What?
Why would that be closer to 0.1 than a lower z-score?
0.01, right?
Oh.
Isn't this 0.01, 02? Isn't that like almost exactly 0.01?
Yes.
Isn't this just even closer to 0.01, just on the other side of it?
I hate rounding. So unspecific.
But rounding loves you. I don't understand. What do you mean? If you rounded each of these, they become 0.01, but which one was closer to begin with? This one.
Why would negative 3.07 or what is that, 8 or 9 not work
Put an
either?
extra O in there. It's 01, not 001. It's 01, not 001. You guys okay out there? No? You suck, Jeff? Let me see. Why dates are, oh, what date? Corrections are due by the day of the final. Okay. So, oh, geez. Okay, here we go. It's pretty cool with that. That is definitely the closest I can get to 1% is right there. 0.0100, isn't 0.0099 really close to 0.0100, right?
Mm-hmm.
Okay, so this is negative 2.33. And so this does make sense. Would I have to go further out to catch more stuff? Yes. So doesn't this make physical sense? If I got to go 1.96 out to catch 95, don't I have to go a little further out to catch 98%?
Yes.
So again, the fundamental idea is if I catch 98% of the data, how certain am I that I caught a specific data point? 98% certain. So I would be 98% confident in what I'm reporting to somebody. If I use these numbers. Okay, stay with me. Now, there is a formula that we have learned that is going to help us because I know z-scores now. I know the z-scores that I want to go out to. How would I convert those back into whatever, fish weights or talking about fish, though I went there, or whatever. How would I convert those back into raw scores? What formula have we used?
X equals?
Yes.
Crap, I just had it. Not what I meant.
Minus is scores.
I don't know what you just said, but I'm just going to go there. Okay.
Yeah.
All right. Does that look at all familiar to anybody?
Yes.
All right, now. So I really want this. So everything I've said so far is old stuff. We just got z-scores from a given situation. The situation was, I want to catch this much data. Okay, so I can get the z-scores for that. Great. But now I want to convert them back into everyday normal things like sizes of shoes or whatever, right? So that's the formula that we have used. Now, the problem is when I go analyze something new, do I know this?
Right now we don't know it.
I don't necessarily know that, right? That's what we're actually trying to estimate, is what the real mean is. So if I just discovered a brand new species of, I don't know why my brain went here, spider, right? Don't like spiders. But I found a brand new species of spider and I know nothing about it. wouldn't I want to take a sample and get some average weights and stuff, and then that would tell me something about the population, wouldn't it? Possibly, right? Unless these spiders are malnourished, and they attack me and my party, and we all die. Anyway,
I would
sorry.
be so hyped to see a new spider.
Me too, from far away. Or National Geographic. Just put it up there. I've seen arachnophobia. So what I'm trying to say is, we normally don't know this. This is what we're actually trying to estimate. So let's convert this idea into something we still. So what I don't know mu, what do I use in place of it? What's the best thing I can use? If I take a sample, like we just said, I take a sample of these spiders. Do I know the average weight of all of these spiders? Magically. The spider I just discovered.
No.
I don't have a clue what the average weight of all these spiders is, right? So what do I use instead? Sorry?
Median?
No. I don't know the
Sample?
population. Yeah, I could use the sample mean. So we take a sample and we get X bar, right? Of size N, let me say it. Now, let me ask you, we took a sample and we're talking about sample means. What else has to change up here?
The standard deviation?
Yes. And then the extra little thing is, this formula can go up or down because the z-score could be positive or negative. But in all of my cases, don't I want to do both? Don't I want to go up and down? So let's just put a plus or minus in the formula and just be done with the damn thing, right? Because I'm always going to go up and down to catch some percentage. All right. So now that I've got that up there and nobody's yelled at me about something specific, let me point it out right now. Section 8.1 and 8.3. Did anybody notice that I do chapter 8 out of order? I do 8.2 at the end. Here's the reason I do that. All right. Let me see how to discuss this. Everybody roughly with me so far? All right. There's a lot of stuff going on.
What is that the equation for, though? I mean, I understand it like on principle, but I don't understand what X is.
X bar. So this is the formula to create the interval, like we saw in that study that I pulled up. It was like 1.03 up to 10 point something or other. This is how you get the interval from something to something. You take, now listen. I wasn't sure what order to do this in, but I might as well do it this order, which is great. If I take a sample mean, I could tell somebody, here's the average, right? But it doesn't really give them a feel for how certain I was about that average. So if I adjust it a little bit, if I go up and down this much, I will then tell them, oh, I'm 98%. If I put 2.33 here, I'm 98% confident that this interval I made contains the real mean. Or if I use these numbers here, then I would say I'm 95% confident that this interval contains the real mean. So
in that situation, do you just decide which percentage you're doing?
You go in either being told what you need to use, or this is the one that's most often used, which kind of makes sense because it's also related to where unusual starts, right? It's roughly 2 up and down. But you could use many different things in whatever situation it is. Okay. All right, we gotta be careful. Oh yeah. So how do you think these two relate to each other? A sample mean versus the actual population mean. Again, are they equal to each other often?
They're close.
I would say if I really took a good random sample and N was relatively big, I would think they would be close. You all with me?
If N is greater than 30, aren't they the same?
No, careful. No. you're thinking about this, which is the mean of all the means.
Right.
Because some sample means be lower, some sample means be higher. If you average them all together, you get the actual mean. Stay with me. I keep getting off track, and now I gotta hold on. So what we're doing is, I really want you guys with me on this. Don't worry, we're gonna get to the concrete stuff here in a minute. Here, I can take this away. I need some room. All right. I happen upon this spider species, right? The actual mean weight is somewhere. This is a number line. Is everybody with me? This is a number line, 0 to something. So the actual mean weight is somewhere. I take a sample. Let's say that my sample mean ends up right there, right? If I go up and down so much, that, like, let's say I go up and down the 1.96. You guys with me? Standard deviations. New standard deviation. Okay. You guys, so if I go up and down 1.96 standard deviations, then I could say that I am 95%, right? 95% confident that my interval from whatever up to whatever contains the real mean. The real, when I say real, I mean population mean. This is more informative than just giving a number. It's an adjustment to the mean, taking into account everything here. So if I take a larger sample, what should happen to my interval? Should it get smaller or bigger? If I take a bigger sample, should it be more or less certain about what I get?
Less. More.
Of course, a bigger sample is always better, right? And sure enough, what happens to this plus or minus piece if n gets bigger? What happens to this if n gets bigger?
It gets smaller.
It gets smaller. So I plus or minus less, the confidence interval goes down, which means I'm more certain about what I see. I don't have to go up and down as much. What if the standard deviation is really big in my data points? Right? So what if the spiders have widely varying weights? Isn't it more likely that I take a sample of a bunch of lighter spiders or a bunch of heavier spiders? I really want you guys with this. So what this formula does is it takes into account these two things, which could affect where my sample mean ends up and how confident I want to be, and creates an interval out of it. So if one group, let's say that there's another research group out there with me, and we got 1.7 grams to 3.1 grams. You guys with me? For the spider. I was going to say pounds, but that's remarkably scary. Let's not go there.
Grams of what?
Spider.
Okay.
We're still talking about the spiders for some reason. It's just too bad. That's where I went. That's where we are. And now I'm thinking about that movie, 8-Legged Freaks. These giants.
I love that movie.
It's an awesome movie. And so I say this is us, right? You and me, we went out for extra credit. We discovered the spider species, and we are weighing them for some reason. And hopefully nobody gets bit. You could hope you get special superpowers, but more than likely you'll just die. And then there's another team, we'll call them, and they get an interval 1.5 to 3.8. And we're both 95% confident. Right? So which one actually seems to indicate that we're more certain about what we got? That we're our error is smaller, that we're closer to the right thing? Which one?
The one with the smaller distance.
Yeah, we are, right? They suck. We're great. It's smaller. So either we took a larger sample, that's possible, right? We took a larger sample, or our standard deviation was just smaller. Now, let's see, what time is it? I told you I'd let you out of here early. I'm going to stick to it. No. Let's just do one concrete problem, right? It's going to take us a while, and then we'll call it a day. Maybe. I got to think about it. Maybe not. We'll see. We'll see how it feels. All right, so let me write this up here. The thing that I thought people would yell at me about is, remember what used to be here in the original formula, right? What was here in the original formula that we replaced with x bar? Mu. Because if we have a brand new thing, we're not going to know what the mean is, are we? We're not going to know what the population mean is. So nobody yelled at me and said, well, you're not going to know this thing either. Dumb stats teacher. We wouldn't know this either, would we? So nobody's yelled at me about it. So that's what section 8.2 covers. Section 8.2 is where we get a new chart. Section 8.2 is where we use a different chart than the z-score chart. Whoa, that sounds great. Now, I really want this to make all the sense in the world. So what the hell good is this shit, Jeff? If we don't know this? Well, sometimes we do know this. So stay with me, stay with me. You can think of a different example, Jeff. You really can. All right, I got it. Oh, that's boring, but who gives a shit? Let's go back to our SAT scores. Isn't this known for the SAT? Wouldn't you say that somebody knows this because they have all the scores, don't they? So don't we know this for everybody? So let's pretend that it's 150, like I said earlier, right? You guys with me? I don't know. You can look it up if you want to real quick. I don't think you could find it. But somebody knows this somewhere, the spread in SAT scores, because it's all in a central location, right? It's in Area 51. So we do know this, but let's go back to my thing where I said I take a sample. I can't remember what mine was. Was it 100? Yeah, it was 100. A sample of 100 students. Are these people a subset of the people this talks about? Yes. Doesn't this talk about all students who take the SAT? I really want you guys, I don't even know if you understand the problem I'm trying to address right now. Somebody out there needs to be concerned that I said, we don't normally know this, so we have to use this. And I didn't say shit about this guy. Because if we don't know this guy, we almost definitely don't know this guy, but you're wrong in that case, because I could be doing a study about a subgroup of people for which I know this. I know how all student scores are distributed. So I'm just talking about a special subgroup of people. Maybe. So I take a sample of 100 students. I get X bar of 1,060. And I want to know, what can I report the amount of points that this seems to possibly add to 1,000. Remember 1,000 was the one for everybody. So I get a sample of 1,060. And what I want to report is it's going to raise your score from something to something, right? Maybe 1,030 to 1,090. Are you guys, I want to be able to say it's going to take your score up by 30 to 90 points. Maybe?
Yeah.
Does that?
What's up?
So I was addressing a problem that I don't think many of you had, which is why it was okay to leave this here, because there are situations where I will know it. So sample of 100. Let's see. Mute everybody.
No.
Yes. Okay. Sample of 100. I know sigma. All I'm missing that I haven't told you yet is, what's the only thing I haven't told you yet that you need? That you need to know.
Z-score?
Yes, and where's the Z-score come from?
Whatever percentage you want to be.
Good. I haven't
Confident?
told you how confident I want us to be when we create this. So let's say I want to be 98% confident. So let me say this real quick. Is anybody surprised that we call these confidence intervals?
No.
That makes sense, right? Math people were incredibly creative. Is there intervals based on confidence? What should we call it? Okay, so we said confidence intervals. This is as far as our brains could take us. We're sorry. So who remembers what the Z-score was for 98% confidence?
2.33.
Yeah, 2.33. Why not put a negative or plus here? Because that's in the formula, isn't it? The up and down is already in the formula with a plus or minus. So now I can throw everything in. 1,060, give or take, 2.33 times 150 divided by the square root of 100. Oh, it's gonna be, what do you know? Sorry, I'm just realizing that my earlier estimate's gonna be pretty close. It's gonna be plus or minus 40. So this piece, is anyone surprised if I call this piece the error? So this is our best guess. This is X bar. All right, let me stop for a minute. The sample that I took, I know exactly what their average was, correct? It was 1,060. But I want to say something about everybody that could take my course. So that's what we're trying to do right now is, based on the sample mean that I got, can I build on that and give people an estimate for anybody who could take my course? So the sample mean for the sample was 1,060. I know that with 100% confidence because I calculated the damn thing. But now I want to talk about people that haven't even taken the test yet. And I want to tell them, here's what you can expect. So this is how much 1,060 is off. Up so much and down so much. That's why we call this the error. So can you guys, so I always calculate the error first. What do you guys get from that? Is that 20 almost? 19.93? I don't know. Or am I way off? Could be way off, Jeff. You could be way off. Or maybe, oh, I'm way off. What was I thinking about?
34.95.
Yeah, okay.
Samsonite, I was way off.
Well, I was close though. I don't know what I just said, but it was almost 30, like I said earlier. Oh, well, screw it. So then this will be, are you guys, is it pretty cool where that number came from? It's just doing this, right? So now I know how much to add and how much to subtract.
You were saying that you thought it was 1,030, between 1,030 and 1,090, which it is.
Yeah, it's roughly, yeah, exactly. That's what I'm saying. So it actually comes out to be 1,025.05, right? Up to 94.95. So in my commercial, I could say, you can expect, I can tell you with 98% confidence that you can expect a score 25 to 95 points higher than average. Does that sound like something you've heard on a commercial before? No? You're like, commercial? What's a commercial? What are you talking about? I just pay a little extra on my Hulu. I don't get no commercials, Jeff. Okay. YouTube still has commercials. What do you want from me? All right. I don't know. Do you guys get a feel for what I'm trying to say here? This is one use of a confidence interval, which I like, actually. I just made this up today. Never taught it quite this way. I like this. So I'm 98% confident. I can say with 98% confidence that 1,025 to 1,095 would contain the actual mean of everybody SAT after they took my program. So I can kind of make that sound better and make a commercial out of it, right? So there's a 2% chance I'm wrong. All right, let me see. Maybe, let me see. Let me think. All right, we'll be fine. Yeah, we'll be fine. Let's do one more thing today and then I'll let us out of here. Well, let's see. Yeah, let's do this. So, well, shit. Yeah, let's do this. I've got a I don't know if you're gonna believe this, but I've got a worksheet. You know, I figured I'd try that out, see how it worked. Let me activate it. Worksheet. Activate. There we go. All right. This worksheet's got a little more. And by the way, before I forget, there's practice quiz 4 up here. That quiz is not happening until next Monday, I believe. But here's the practice quiz, right? Doesn't that look familiar? Kind of stuff. Yay! And there's also already the solutions video is up here also.
Sweet.
This one I can't blame on far past Jeff because this is one I just made today. So I have to blame on the recent. I made a mistake. So now you should be able to see this handout. Section 8183 handout. And this will happen someday. There it is. So this is talking about dolphins. So let's try this out real quick. Because you're gonna love this. You're gonna love this. Oh, there's something here that you're gonna so love. Let me open this a different way. Sorry.
You're gonna like the way you look. I guarantee you.
I guarantee it. I don't always wear a suit. But when I do, I get out of it as fast as I can. All right, let me see.
Dos Equis commercial combined with Men's Warehouse.
Dos Equis. It really takes the edge off if you're wearing a tie. Shit. What was this called again? Jeff. Confidence. There you. No. There you. No. Damn it. Rawr. All right. Hold on. I gotta go further back. There you are. Hopefully it's the same one. That would be really nice. I think so. All right. Let me open this up. Okay. Let's see. Nice, concrete, fully fleshed out problem. Dealing with dolphins. I like it. So we took a sample of 37 dolphins to find their average length to be 92.6 inches. We already know. So let's say that we're off the coast of some island and we're concerned because there's, I don't know, factory on this island that's possibly putting out pollutants, and we want to see if the dolphin population is being adversely affected physically. Is everybody kind of with me? That's one thing we could be doing. So we know the standard deviation of all dolphin lengths. It's just accepted to be 4.11 inches. Right, that's pretty specific, but oh well. Let's pretend like we're in this universe where this is true. I think I looked this up. I can't remember. So the very first thing I ask you to do is just kind of summarize stuff from what I told you. So can somebody help me out? What was X bar for this problem? X bar. Anybody know what X bar is in this problem?
92.6.
92.6.
92.6.
Yeah. Wanted one more person to come in. I think it's 92.6. That was perfect. All right. Now, What's sigma?
4.11.
Yeah, I make that really clear, right? 4.11. So if you're ever in a problem, you're not sure if it's a population standard deviation, it most likely is a sample standard deviation, because if it's a population one, you're gonna know. If a statistician has a population piece of information, we're gonna be like, I got the freaking population, holy shit, because we're not used to that shit. So that's why I was all like, holy shit. And then what's N, of course?
37.
Right, 37, okay. We already should know this. I've got this whole little thing, but we just did this a minute ago. Who remembers what the Z-score was for 95%?
1.96.
Yeah, 1.96, up and down. And the up and down piece, again, is in the formula already. So put a positive Z-score in so don't get all freaked out. So now we got everything we need. Just got to throw it in there and do it, right? So I got these dolphins off the coast of this island. I've gotten a sample of them, and now I want to get a feel for what the actual population mean of these dolphins off the coast of this island would be, and see if it's less than the average of all dolphins, because then I'm going to get concerned that these dolphins are being adversely affected. So let's see. Where are you? 1.96, 4.11, 37. It's 2, 8, 4/3, 1.35. Get a calculator, Jeff.
$1.32.
Holy shit. Come on, that's pretty good, right? Come on. So in general, what you want to do is you want to take this one more place out than this. So that was perfect what you just said. So then now it's been a while, but I still remember the time a student came up to me and said, where's the plus or minus button in my calculator? There you go. Somebody would appreciate it. So of course you just subtract that and add it. So, and that'll give you your floor and your ceiling. So you get 91.28, right? Up to 93.92, is that right? Yes. So I sort of got you ready for this next thing.
So that's your confidence interval.
That's right. That's my confidence interval. So the interpretation of that. So a confidence interval problem is not complete until you write a statement interpreting what you just found. That sounds fantastic, Jeff. So my conclusion is we are farmers. No, we are, how confident are we in this problem?
95.
95. We are 95% confident that our interval caught the real mean. So now we get more specific. That the interval 91.28 watts to 93.92 watts units are necessary. What are the units here?
Inches.
Inches. Contains the real, right? I call it true population mean length of dolphins in this area. So, is that evidence that their average is less than 95 inches? Have we found evidence that their average is less than 95 inches? For example, anybody?
Yes.
Yes, because our entire interval is below 95. You guys see that? We are 95% confident that this interval we discovered contains the true mean. So more than likely, I mean, this is evidence, not proof. Notice I did not say proof. You can never get statistics, holy shit. But it's good evidence that their average length is below 95. And what if the average length of all of the species of dolphin is 95? Is that evidence that something weird is happening around this island? Are they growing as long as they're supposed to? No. Is that evidence that there's something weird happening around this island? Yes. Now, is it proof? No. I'd go in and do more analysis, wouldn't I? I'd take a larger sample. I'd take a water sample, have it analyzed. I'd see if biologists can explain if there's an actual effect. Do you understand what I'm saying? But this would be a good initial thing to do, to see if there's even something to go further deeper into, right? So I see something physical. There's evidence, not proof, but there's evidence that they grow shorter than they're supposed to, than I would expect. So let's look deeper. Is there a chance that they just happen to be shorter dolphins? Or that my sample just happened to be shorter? Is that possible? Shit, yeah. There's a roughly 5% chance that I'm wrong somehow. Now, the actual story is a little bit more complicated than that, but that's actually pretty decent as to how to understand it right now. So all a confidence interval really does is improves upon a single number for a mean or a percentage. Gives a range, so I get a better feel for how certain things are altogether. Without doing this problem, without actually doing it, would the 90% confidence interval be smaller or larger, meaning wider, narrower or wider?
Or narrow.
Yeah, it would be more narrow because it only has to catch 90% instead of 95. So I can throw out a smaller net. I don't have to catch as much data. Okay. Like it.
Wait, I think I got that one a little confused. I would think that if you're 90%, then you're less confident about something. Is that what that means?
90% means we're less confident. And what is it that, listen, what is it that tells me how confident I am is the amount of stuff I catch.
Oh, so your window would be larger.
For 95%. So if my 95% looks like this,
The more you catch, the more confident you are in its
so if I want
accuracy.
to allow myself to be less confident, that means I have to catch less stuff. So I go out less. It would be narrower. That is that word will make you sound drunk. Narrower.
Okay, because in my head I had like 90% means that you have a wider range that can fit into it.
Yeah, that's what I was thinking too.
Yeah, that's what my brain went to, but this makes more sense. So
it makes more sense. I really don't understand the way you were looking at it, to be completely honest. But as long as
no, I got it. We're good.
Because I can't even explain why it isn't the other thing you said, because I don't even understand it. But is everybody else decent with this?
Yes.
Okay. So I think last thing, well, no, I think that's enough. We'll get into this next time. That's enough for today.
E.
What's that? Do you have an eye chart? Did you start reading off an eye chart?
Oh, why is there an E there? That's scary.
Oh yeah. Well, what do you think that means? What was this piece again? What's the name of this piece?
Error.
Error. So the E probably stands for error.
Oh.
So what this is going to do is if I know how off I want to allow myself to be, I can see how big of a sample I need to take. So that's the next thing we'll do. That's enough for today. So let me know if you need to hang out afterwards. Otherwise, sorry. Go ahead.
I need to hang out.
Okay.
Hey, I have a question for the homework.
Yes.
So it says every third one. Do you mean like, so for the first one it says 2 through 8? Do you mean like the second one?
That's 2 through 8. The every third one is attached. Let me see, which problems was this? There it is. 2 through 8. 2, 3, 4, 5, 6, 7, 8. 12 through 30, every third one. So just count by threes. 12, 15, 18, 21.
Oh, okay. Okay, got you. Thank you.
Yeah, those are just all similar problems. So I didn't have to assign like every one of them. So I just did a swath through it. Okay. All right. Let's see who's really here. There they go. It's like popping bubble. All right, Jordan, what's up?
I'm gonna go print the midterm paper real quick before I ask you questions. Is that okay?
Sure.